So, continuation of the exercise modes, question number 3. The equation for the reaction is shown as sodium is reacting with water. It produces sodium hydroxide and a hydrogen gas is there. And the question is calculate the concentration of sodium hydroxide NaOH aqueous. Look, when something is aqueous, means aqueous or dissolved or it's a solution. So you can also identify whether a substance is solution or a gas. So from the state symbols, you can see the state symbols are given here. Sodium is solid, water is liquid, sodium hydroxide is aqueous, and hydrogen is a gas. So this is our main question. Like the final answer, we need a concentration of sodium hydroxide in grams per dm³. This is what we need. But to reach this, you have to follow the step, you have to follow the sequence. So when 0.345 grams of a sodium is added to 50 cm cube of a distilled water, that's a volume of a water, or that will be same as the volume of the solution. There is no change in volume. The volume remains same. Calculate the number of moles of Na. So we have the mass of Na. We have 0.345 grams of Na. Which formula is valid? If you have the mass of Na, which formula is valid? First, second, or third? So we have the mass. So whenever we have the mass, which formula is valid? The first formula is valid. The mass in gram is there. So you'll use the first formula. You can write in short that moles equal mass in gram, small m, divided by molar mass, capital M. Mass in gram, what is the mass in gram? That is 0.345. What about the molar mass? Molar mass can be atomic mass or a molecular mass depending on the substance. Because this is sodium and the symbol sodium is Na. So in this case, the molar mass will be atomic mass. So what is the mass of Na? You have to use a periodic table. You will see here is sodium Na, and the key is given that the relative atomic mass is the bottom. So 23 is a relative atomic mass. So this will be 0.345 divided by 23. What's the answer for this? When you divide, what's the answer? 0.345 divided by 23. Zero 0.015. Okay. So this will be 0.015. We got the moles of Na. So first, we use a formula and we got the moles. Is it clear, the first part? How we worked out the moles? Anyone is having a doubt or a question in the first?
Clear, sir.
Okay. The second part, we need the moles of NaOH, sodium hydroxide. So how we work out the moles of NaOH? Because we don't have any information about NaOH. Nothing is given about NaOH except the volume. So what we'll do, how to solve the second part? The second part is by using a ratio. What ratio we will take? We'll take a ratio between the quantity which we calculated in the previous to a quantity which we need now. So here we'll take a ratio between sodium and sodium hydroxide. How many moles of sodium are there in the, for ratio you have to use the equation. How many moles of sodium are there in the equation? 2. Right. So 2. And how many moles of sodium hydroxide are there? That's also 2. So we can say they have the same ratio, like ratio is 1:1. So if we have 0.015 moles of sodium, how many moles of sodium hydroxide will be there? X. So we just cross multiply. So even when the ratio is 1:1, 2:2, you don't have to solve. It is obvious. We'll get the same answer. If 2 moles are giving 2 moles, then 0.015 will give us the same answer. So it will be also 0.015. Is it clear? The second part, anyone having a doubt or a question in the second part? Feel free to ask your doubts, any part if you're not able to understand or find it difficult. You can just let me know, so I will repeat that part. Then calculate the concentration of sodium hydroxide. We need the concentration. So if we need the concentration, again, as we solve, the first part we solve by using a formula. The second part we solve by using a ratio. And the third part, again, we'll use a formula. So we'll use a formula to solve the third part. So how to work out which formula to use? Again, you have to check what we have now. We have the moles, because we have the moles of sodium hydroxide, which are 0.015, and we have the volume as well. Because the volume of a distilled water or a volume of a solution is 50 cm cube. So we have the volume of the solution, which is 50 cm cube, or it must be in dm cube. So that is divided by 1000, 0.05 dm. So we have the moles and volume. So which formula is valid if we have the moles and volume? So we'll use a formula. Moles is concentration time volume. Because we need the concentration, so we substitute the value. We have the moles, which are 0.015. Concentration we don't know, and the volume is 0.05. Cross multiply, like divide 0.015 divided by 0.05. What's the answer for this when we divide? 0.015 divided by 0.05. What will be the concentration? 0.015 divided by 0.05. So that's right. The concentration will be 0.3. Yeah. So this will give us 0.3 moles per dm cube, the concentration of the sodium hydroxide. Is it clear? The third part. Any doubt in this third part?
No, sir.
Okay. Now, the next part, we just have to convert the concentration from moles per dm cube to grams, because the question is now determine the concentration. How did we find the volume? The volume is given here. In the question, the volume is given 50 cm cube. That was the volume of the solution. Volume of a distilled water will be same as the volume of sodium hydroxide. The next, we want to convert the concentration from mole per dm cube. Like this answer was 0.3. We want to convert the moles per dm cube to grams per dm cube. So simply what you have to do, you have to multiply by molar mass. So molar mass of a sodium hydroxide, like if we want to convert the concentration from mole per dm cube to grams per dm cube, simply multiply by molar mass. And what is the molar mass of a sodium hydroxide? Sodium is 23, oxygen is 16, and hydrogen is 1. So 23 plus 16, 39, and 39 plus 1 makes 40. So what we have to do, we have to multiply this 0.3 by 40. So when I multiply 0.3 with 40, I will get this as 12. So we'll get 12 grams per dm cube. the concentration of sodium hydroxide. So mole per dm cube is also a concentration. Grams per dm cube is also a concentration. Mole per dm cube means like how many moles in 1 liter or 1 dm cube, and grams per dm cube, what mass is there in 1 liter or 1 dm cube. So usually they ask this question, the last step, converting the concentration from moles per dm cube to grams per dm cube, you will multiply by the molar mass of the molecule or the molecular mass. So whenever the rule is converting the concentration from one unit to another, because grams per dm cube is also a concentration and moles per dm cube is also a concentration. So if we have moles per dm cube and we want to convert into grams per dm cube, what is the rule? The rule is you multiply by the molar mass. So this was 0.3. We want grams per dm cube. So you multiply by the molar mass. Molar mass of sodium hydroxide. Sodium, you will use a periodic table. Sodium is 23, oxygen is 16, and hydrogen is 1. So 23 plus 16 plus 1 will make total 40, the sum. So total, the molecular mass or a molar mass is 40. So what you will do, you will multiply 0.3 by 40. So when 0.3 is multiplied by 40, you will get 1.2 grams per decimeter. Is it clear, this one, the last part? Okay, it is 12. Sorry. Yeah, when you multiply 0.3 by 40, it is 12, not 1.2. Next question. So you always follow the steps. In the question, we have 20 cm cube of 0.1 mole per dm cube H2O2, which is a hydrogen peroxide. And it decomposes into water and oxygen in the presence of the catalyst. Calculate the number of moles of hydrogen peroxide used in the experiment. So we have the volume and we have the concentration. Which formula is valid if we have the volume and concentration? Which formula I should use if I have the volume and concentration? First, second, or third?
Third.
So we'll use the third formula. So we'll use the third formula, that moles equal concentration times volume. The volume is 20, but that is in cm cube. So what I have to do? Concentration is 0.1. So to convert the cm cube into dm cube, what I have to do?
Divide by 1,000.
So we'll divide by 1000. How to figure out which is a concentration and which one is a volume? As you know, the unit of, from units you can identify. What are the units of the volume? The units of the volume are in cm cube or dm cube. What are the units of concentration? The units of the concentration can be either mole per dm cube or grams per dm cube. So this is mole per dm cube. So means this should be a concentration. This is only cm cube or it might be a dm cube. Then it will be the concentration. So using a unit you can identify. So moles equal concentration times the volume. So we divide by 1000, 0.02. So this will be 0.002 will be there. So we solve the first part by using a formula. The next is use your answer and the equation, calculate the number of moles of oxygen. How we can work out so second part we solve by using a ratio. What is the ratio between, because we work out hydrogen peroxide is H2O2. And we need oxygen, we need O2. What is the ratio between hydrogen peroxide and oxygen? So the ratio between them is 2:1. Like hydrogen peroxide is 2 and oxygen, how many moles of oxygen are there? 1. So for ratio, we always use the equation. So hydrogen peroxide and oxygen, the ratio is 2:1. How many moles of hydrogen peroxide are there? We have 0.002. So how many moles of oxygen should be there? X. We cross multiply. So this will be 2x and this will be 1. So this will be 2x is equals to 0.002. Then x will be equals to 0.002 divided by 2, which is 0.001 mole. Is it clear? The second part? Any doubt in this?
No, sir.
Okay. Now, so first part we solve by using a formula. The second part we solve by using a ratio. The third part, again, what we will do, if you want to solve the third part, again, we'll use a formula. So you can see a sequence is there. I use a formula, then I use a ratio, then I use a formula. Most of the question is like 90% of the question is always having a sequence until unless some exception question is there, but most of the questions are solved in this manner. What is the meaning of RTP? RTP means room temperature and pressure. Like room temperature means 25 degrees centigrade and pressure is like 1 atm. Calculate the volume at RTP of oxygen. Oxygen is a gas. So we need the volume of a gas. So which formula we should use if we need the volume of the gas? The first, second, or third? Which one? Which formula I should use to get the volume of the gas?
Second.
So I'll use the second formula. Because the second formula involves the volume of the gas. So we already have these answers, like this was 0.002 was there. This was 0.001. Now we need the volume of the gas. So the formula moles equal volume of the gas divided by 24. Moles of oxygen we already calculated 0.001. Volume we don't know and divide by 24. 24 is divided, other side it will be multiplied. So when 0.001 multiplied by 24, we'll get 0.024 decimeter cube. So this will be the volume of oxygen. So that's how we work out the volume of oxygen. Is it clear, the third part? So in the third part, sure, I will repeat. In the third part, we need the volume of the gas. So for the third part, we need the volume of oxygen, and oxygen is a gas. So the formula that moles equal volume of the gas divided by 24. That's the third formula. Moles of oxygen, which we calculated in the previous part, was 0.001. Volume of the oxygen we don't know, and divided by 24. That's a part, 24 is a part of the formula. It's a molar volume, like it's a volume of 1 mole of any gas will have 24 dm cube. This 24 is divided, other side it will be multiplied. So 0.001 multiplied by 24. So when we multiply, we got 0.024 decimeter. So if we need the volume of the gas, we just need the moles. If we know the moles, we can find the volume of any gas at room temperature and pressure. The fourth part is actually related to another chapter, which is about the chemical reactions. You will learn about it. What will be the effect of the on the volume of produced if the mass of a catalyst increase? The catalyst does not have any effect on the volume of the gas or volume of a product, so there will be no change. Reason you will learn in later in this topic 6, which is about the chemical reaction. You will learn the reason. And the last part, so fourth part is like still we did not discuss that, so I'm not going in detail. About the fifth part, reduce the volume of a gas if 20 cm cube of 2 mole per dm cube of hydrogen peroxide is used. Like first we were using 0.1 mole per dm cube hydrogen peroxide, and what amount of the oxygen we got? We got 0.024. The question is, if I double the concentration, double amount of hydrogen peroxide, what is the volume of the gas produced? If I double the concentration of a hydrogen peroxide, what will be the volume of gas produced? So if 0.1 mole per dm cube was giving 0.024 dm cube. So if I double the concentration, double the amount, what will happen to the volume of the gas? The volume of the gas or the volume of a product will also be doubled. So 0.024 multiplied by 2, it will be 0.048. So if I use more reactant, I will get more product. That's why, like, if I double the amount of reactant, I'll get the double product. So if 0.1 mole per dm cube was giving us 0.024, so if we double the amount of the reactant, like the hydrogen peroxide, we make it 0.2. So the amount of the product, which is the oxygen here, a gas, that amount will also be doubled. So 0.048 will be the volume of oxygen if we double the amount of hydrogen peroxide. Is it clear, this part? Question 6. Silver chloride can be made by reacting aqueous sodium chloride with aqueous silver nitrate, like mixing two solutions. Aqueous means like solutions are there, this is solid and this aqueous. A student started with 20 cm cube of 0.2 mole per dm cube NaCl. Determine the amount used, means we need the moles of NaCl. How to get the moles of NaCl? So first part we solve by using a formula. But which formula I should use? I have the volume and I have the concentration. Which formula is valid here? First, second, or third? Because I have the volume and I have the concentration, so I should use the third formula. First, I cannot use. Why I cannot use the first formula? Because I don't have the mass. If you read the question, in the question we have the volume. We have the volume here. And we have the concentration. So volume and concentration, then we use the third formula. So third formula is concentration times volume. Concentration is 0.2. But what about the volume? It is 20 cm cube. So how many dm cube will be there? How many dm cubes? Volume should always be in dm cube. Concentration is 0.2. but volume is in cm cube, so I have to substitute in dm cube, so 0.02. Because to convert the cm cube into dm cube, what we do? We divide by 1000. So a very common mistake from students that they forget to convert into dm cube and they just write 20 is there, they write 20. You will get a wrong answer. So remember always, whenever you are solving a moles question, the volume must be in dm cube. So when you multiply them, the final answer will be 0.004 dm cube. Centimeter cube, we have to convert into dm cube. 3 by dividing with 1000. So this will be 0.004 moles will be there. Is it clear, the first part? Now, the second part, we need the mass of sodium nitrate. We need this thing. But we don't have any information about sodium nitrate. So first we should know the moles, and then from moles we'll work out the mass. How to work out the moles of sodium nitrate first? So you will take a ratio. What ratio you will take? You will take a ratio between sodium chloride and sodium nitrate. What is the ratio between sodium chloride and why we are taking this ratio? Because we have sodium chloride and we need sodium nitrate. So ratio between them is 1:1. And the first part we solve by using a formula. Now second part, we first started with a ratio. So 1:1 is a ratio. If we have 0.004 moles of sodium chloride, then X moles of sodium nitrate. How many moles of sodium nitrate will be there? 0.004 moles of sodium nitrate. But in the question, they mentioned the yield is 90%. What does it mean? Yield is 90%. Means we are only getting 90% of what we should get. Like we should get 0.004, but we are getting 90% of this amount. According to a ratio, if 1 mole is of sodium chloride, it will give 1 mole of sodium nitrate. So if we have 0.004 moles of sodium chloride, we should have same number of moles of sodium nitrate, which is 0.004. But in the question, they mentioned that we are getting 90% yield, or we are getting 90% of the amount what we should get. So what is the 90% of 0.004? So what is the 90% of 0.004? How to convert? So it will be 90 multiplied by 0.004 divided by 100. That's how we take a 90% of 0.004. We multiply by 90 and divide by 100. So when we do this, we'll get the mass of sodium nitrate, which is 0.0036. Okay. So we got 90% of this, the mole 0.0036 moles. Is it clear till this point? Anyone having a doubt or a question? And the last part, we need the mass. So last part, we need the mass. So how to convert the moles into mass? Because we have the moles, we have to find the mass in gram. The question is mass of the sodium chloride crystal. So how we work out, I'm solving it here, that we have the first formula that moles equal mass in gram divided by molar mass. So moles of sodium nitrate are 0.0036. Mass in gram, we don't know. What about the molar mass? For a molar mass, you have to use a periodic table. From a periodic table, you'll find sodium is 23, nitrogen is 14, and oxygen is 16 multiplied by 3. So it will be 48 plus 16 plus 23. So the total will be 85. So the molar mass is from the periodic table, using a periodic table, and this 0.0036 multiplied by 85. What's the final answer? 0.0036 multiplied by 85. 0.306. Okay. So we got 0.306. I'll repeat this question. Look, what we did in the first part, we have to determine the amount of NaCl, the moles of NaCl. We have the volume of NaCl and we have the concentration of NaCl. So we use a formula that moles equal concentration times volume. The concentration is 0.2 and the volume is 20 cm cube, which we convert into dm cube divided by 1000. So don't forget to convert the volume into cm cube, dm cube by dividing with 1000. So 0.2 multiplied by 0.02, we got the moles of NaCl. But in the question, they mentioned that only 90% yield is there, like we are only getting 90% of what we should get. We're not getting 100% amount. We're getting a 90% amount. So when we use the ratio, first we find the moles of sodium nitrate by using a ratio between sodium chloride and sodium nitrate. The ratio is 1:1. So if we have 0.004, then X moles of sodium nitrate, we got 0.004 moles of sodium nitrate. But that is, if it was a 100% reaction, 100% yield was there, we should get 0.004. But they mentioned we are getting only 90% of what we should get. So what is it? 90% of this total amount. So 90% of 0.004 is 0.0036. And these are the moles of sodium nitrate. When we multiply by the molar mass of a sodium nitrate, we'll get the mass in gram, which is 0.306 grams of sodium nitrate will be formed in this reaction. So this was again a moles question, a different type of a question compared to what we have solved in the previous examples.